Hey everyone, welcome back. This is day 4 of January, and we will be solving this daily question for the 4th of January. Now, this is another question which is on the medium level but is quite easy. And how to say this? The question isn't that complex as yesterday's question, but yeah, it's fairly easy to, figure out a pattern in the test cases or in the provided list of entries or question in general. Basically, it's easy to figure out a pattern that we can use as a solution here. So here is the question. Let's go to the question quickly. We have been given a zero indexed array. Great. We have two. We have two types of operations that we can perform on that array. We can remove two elements with equal values and delete them from an array, or we can three elements with equal values and delete them from an array. So basically, this means that if there are two elements, let's say A, then we can remove those two. And if there are three elements A, then we can remove these three at once. So that's it. And if we have an element, a single element, then we cannot. Of course, we cannot, remove it, remove two of it or three of it. So we have to return -1 in that case. So this is an example. Let's go to the whiteboard for the example. So here, as you can see, I got the example that in the question there, and let me quickly get the pen. Where's my pen, man? Yeah, there you go. So if I were to remove items from here, two, okay, I can remove two twice. So I can perform the operation of removing two items at once twice, and then I can do the same for 4. I can remove 2 of 4s, and if I were to remove 2 of 3, I'll basically have a 3 remaining in the array. I cannot do that because we have to remove all the items. We have to basically get the maximum number of operations that we have to perform to remove all the items from this array, right? So we can't do this, but we have the option to remove 3 items at once. And if we do that, there you go, we have an empty array now. So therefore, if I were to count this, let me actually color it differently. This is one. This is two operations. Wait, yeah, this is one operation and this is one operation. So 2. Then no, not 3. 4. Removing 4 would be another one operation. So we are at 3, and then lastly, removing 3, which adds one more, total 4 operations, which is the answer. Great. Now, one way to basically make sure that all these counters are calculated is basically to make a hash map and get the frequency of everything. So if I were to create a hash map here, that would be for value 2, I have frequency 4. For value 3, I have frequency 3, and value 4, I have frequency 2. And since 4 is divisible by 2, I can do 2 operations. For 3, I can do 3 operations. And for 2, I can do just one operation. 2 plus 3 plus 1, 4. There we go. We get the final answer. But let's say, what if instead of 2 4s, I had 6 4s? Now, do I go for 2 2 2 or 3 3? Note that we have to calculate the least number of operations that we should perform. So following that, we should go for 3 3, right? Removing 3 4s and then removing 3 4s again. So this is the dilemma here, basically. Now let's look at the pattern that I was talking about. Okay, let's erase this completely. Now let's start with 1. I cannot perform any operations on 1. So if I encounter 1 anywhere in my array, I'll just return -1. Let's come to 2. 2 can be removed like 2, basically this is not the value, this is the frequency. Let's say B has occurred twice. So I can perform 2 operations to remove B, basically. So 2 can be removed with that. If there are 3, then I can just remove them with the operation of removing 3 items, basically. But if there is 4, then we have 2 plus 2, right? For 5, we have 2 plus 3. 6, we have 3 plus 3. 7, this 3 can convert into 2 plus 2 plus 3 again. So you can see a pattern here, right? Basically, almost all these numbers are divisible by 3. As you can see here, one number, this one is divisible by 3, this is divisible by 3, and if I have 9 here, that is 9 would be 3 plus 3 plus 3. So we will get how to say this, a few numbers in every other interval where these numbers are divisible by 3, and we have to be greedy here because we have to make sure that we reduce the number of operations that we perform. So 3 would be the best number to perform, start with. Now what we can do is, let me quickly get this out of here. Okay. Again, 1 will return -1. What we can do for 2, 3, and then after 3 is, what if I add 2 to it? 4 plus 2, 6. Now, 6 divided by 3 is 2. This means that I have to perform 2 operations. And if I were to go for 4, originally as well, I can remove 2 items twice. And then that will really lead to, again, 2 operations, right? So that's one thing. And similarly for 5, if I were to add 5 plus 2, 7. 7 divided by 3, I'm just getting the question now, would be 2 again. So I can remove 5 elements with 2 operations, which is removing 3 elements and then removing 2 elements. So similarly for, let's say, 21. Okay, 21, if I were to add, no, 21 is divisible by 3. Let's go for something that is not divisible by 3. 23. 23 plus 2 is 25. 25 divided by 3 would be 8. So I'll need 8 operations. So if there are 23 items, I'll need 8 operations to remove all those 23 items. So this way we can get the value. If I were to give you even simpler explanation, it's basically like getting the ceiling of dividing any item by 3. So I'm adding 2 to the item and then dividing it by 3 instead of using the ceil function. That's it. Let's code now. Okay. So we'll first declare a frequency hash map. It will have all the frequency basically, or for now I'll just use the counter function. I think it should work without calling the collection, importing collections. And we'll use this variable top count, which will basically count the number of operations that we have to make on the array. For I don't need the key value for underscore count value. Sorry, and sorry, items if value double equals 1, return -1, and I don't need the else. Op count that equals popcorn, basically popcorn equals popcorn plus. What will we add? We will add value plus 2, and we need a quotient when we divided by 3. Popcorn. There we go. 40 milliseconds. And if I submit it now, 576 milliseconds, which is fair. I think other people are maybe using DFS or dynamic programming, and they might be writing their output to a file. So that's maybe saving a lot of time. But I'm fine with this. This is a good solution. Okay, then. See you tomorrow. Bye bye.